All right. So, yes, I'm going to be doing this short live stream to introduce LabSimDev, this simulation environment that I learned about last week at a summer school in Pisa, where I met the developers of this software and a lot of academics working with it to create economic simulations. And I was quite excited to learn about it. And yeah, I guess I'll be using this a lot in the coming years. At the moment, I'm a beginner in this tool. I've been doing some simulations with AnyLogic and Hash.ai, and I might at some point show the kind of comparison between those and this. Each tool kind of has its own advantages and disadvantages. The disadvantage with this one is that you're programming in C++, which is not a modern programming language and not that popular a programming language. Growing up as a kind of web kid with HTML, CSS, JS, and then now Python, yes, it's a bit painful to be going to C++, but there is a lot of advantages to it. The primary one, which the developers kind of harp on about, is the efficiency. When you want to do really large simulations, it doesn't matter how efficient the simulation is. And Python is not, I think, much worse. Well, much, like it might be 2 or 3 times worse. But there's certainly other programming languages that will do 20, 30x or 100x worse. So at some point, I might try doing some of these things with Python, maybe with Hash.ai, or also with Java and AnyLogic and see, although I'm not a huge fan of Java, but also to see the performance comparison. But for now, I have this kind of idea of doing 100 levels of economic simulations, kind of starting with the most simplest simulation I can possibly imagine, and then building on one more thing with each level. And so when I start with level 1, there's like 3 components, and when I get to level 100, there must be at least 100 components, 103 or more. I guess there will be more because there's certain points where you can't just add one thing, you have to add 2 things to kind of balance things out. So there might be 200 plus components. And at the beginning now, it's kind of, you could say it's almost not really a simulation. It's just no, actually, that's not true. We're gonna do something that is really a simulation, but in some ways, you could say it's analytically solvable. You could mathematically figure out what the solution to this is. But we're gonna add some randomness that makes it a little bit more interesting than that. But there's no agents in the sense that there is behavior of agents that interact at the beginning. No, that will come pretty quickly, I think. Because that's what makes this whole approach, the simulation approach, so interesting, is that you can see the interaction between different participants in an economy and how that interaction sort of has these feedback loops, which is kind of what makes the whole thing so interesting and so important to simulate, I think. So my interest in simulation is because I think we can understand and predict economic trajectories much, much better when we simulate them. And agent-based modeling is the simulation approach that makes that possible. And that's what this tool is built for, and that's what I want to use it for. But to start with, there won't be agents as such, but we'll see as we go. So first of all, LSD is this LabSimDev simulation software. It's a tool that's built on top of C++. You have to code to some extent in C++. There's a lot of kind of C++ macros that they've built on top that make it relatively easier to do things. And there's a lot of things you don't have to do. Like you don't have to write any code to progress time, for example. Time is automatically progressing. And before I continue, I think I want to briefly show some of the documentation. So this is the LabSimDev website. here, I've just been kind of looking at some of the macro language, and that's sort of my reference documentation that I refer to whenever I get stuck, whenever I need to figure something out. But I'm going to put that aside for now. And I want to just sort of, we're going to create here a new model. And we'll say, yes, we want to put it in the working directory. I'm just going to create this model in the current group. And I'm just going to call it level 1. So, and I don't need a description file for now. We might need that later when we make bigger models. We have some outline code here created for us. And at the end, what we're going to do actually is write these equations in here. The syntax for equations is just we write capital equation, open brackets, to give the equation a name, and then at the end we return something in brackets. And so the name, so let's say, for example, we want GDP is the first, if we start modeling an economy, then GDP is sort of one of the most obvious things to try and model. And so that's going to be the first thing I put in here. And now I could just put a number in here. So I could put 1, let's say. And now I have a simulation that at every time step says GDP is 1. Okay, not very interesting. But that's the start of how this begins. Okay, so what we actually want is for GDP to be calculated using, let's say, GDP growth. So let me just put in here. If I wanted to write multiple lines, I could write them here. I could also write 1 line of code in here to say, like, a formula that calculates GDP. So I think I'm just going to write it. I think for my sanity, I'm going to separate this out. So there's a syntax which allows you to declare temporary variables like this. And I'm going to just create this temporary variable. And that's what I'm going to output. So this temporary variable is going to be the GDP from the previous period. So I'll call this GDP T-1 plus the GDP growth since the last period, right? Which is like the current GDP growth. And this is now in absolute terms. Okay, so the syntax is not correct yet, but just kind of for us to think about this, I'm just going to write it like this for now. And then I need to create an equation for GDP growth. So that it needs to be calculated in some way. And let's say that also returns, like at the end, we're going to put that in this V0 variable and in here. That's local to the equation. So this V0 is not the same as this V0. And then this GDP growth, and GDP growth we're going to calculate as the GDP also from last period, and this time times the GDP growth rate. Okay, so if the growth rate, say, is 3%, then you take 3% times the GDP from the last period. Let's say that's 1,000. Then you get 30 as the GDP growth for this period. And then you take the 1,000 from last period and add the 30 from this period, and that gives you 1,030, which is the new GDP for this period. So that's how we've got GDP growth. So now we just need one more thing, which is we need the GDP growth rate. And so the GDP growth rate, and this could just be like, let's say 0.03. This could be just 3%. But at this point, I think this is where we're going to add some variation. So we're just going to say this is going to be plus a normal distribution centered on 0 with a standard deviation of, let's say, 0.01. So it will be some variation, but not that much. And then again, we're going to do this return the v0. Okay, so now I'm just going to fix the syntax. So in each case, we're going to set these as v0. Okay. And now what I need to do is put in the syntax for calling these variables. So this one is a little bit more complicated. So let's call these first. So you call a variable by just using this shortcut v and then putting the name in brackets. And that just tells LSD to go and get that variable and give you the number of the current version of that variable. So not the lagged one. And this one is fine as it is because I'm not calling any variables. And that is already the correct code for getting a normal distribution. Okay, so now these lagged variables are defined slightly differently with this variable with a lag, VL, and then we give the name of the variable, so in this case GDP, and then we just do comma, and then we say how many lags we want, and then we close brackets. So yeah, that's GDP t minus 1. And if I put this here as well, now we have the three equations for GDP, GDP growth, and the GDP growth rate. Yeah, I think this is the most simple possible system of equations for GDP. I mean, obviously, we could kind of collapse some of these. We don't need all three of these. We could just have the GDP and the GDP growth rate and, you know, put this equation in here. But I think it's nice to separate them out so you see kind of what's happening a little bit more explicitly. But we're not quite done yet because now I have to compile this. I'm going to save it. And now it's being compiled into the, okay, now I have error. So it wants these colons afterwards. I don't know why, because I think I've been able to do this without semicolons. I feel like I might have done something else wrong. Well, I'm going to add the colons, semicolons. Oh, I know why. This should be result and not return. I'm getting confused. Yes, now we can see the color change. That is, these semicolons are necessary, I think, in certain situations, but not when you just declare variables and show the results. Okay, and that has worked. I need to pull these things in here. So it's now compiled this model into LSD. And so there's two softwares involved with LSD. Actually, there's this LMM, the LSD model manager, and then there's LSD, which is where you actually then run the models. And there's a bit of configuration that's needed here. It's actually relatively simple. In this case, we have these three variables. You could say that the GDP growth rate is a parameter, but actually I don't want it to be fixed every period. So a parameter is always fixed. And in this case, I'm calculating it with this normal distribution every period. So I think I'll declare that as a variable as well. So we can add on press on this Lego brick, and then we can use this drop down. It tells us what variables we've got in the model that are not defined in this configuration yet. And then I just give that. And for the GDP, because I'm calling it with a lag, I need to give here the lag as well. So I'm going to press that, and also we're going to need to give it initial values. So for GDP, the initial value is 1,000. Well, let's make it 100. I mean, it doesn't really matter, but okay. So that's that. And now I can add the other two, which don't need lags and don't need initial values. But what I do want is for them to show up in the plot. Oops. So we're just going to do that. Save and runtime plot. Save and runtime plot. And save and runtime plot. Okay. I think that should be it. I'm going to try running it now. I need to save it first. So that's fine. And now we're going to run it. There we go. It happened instantly because, yes, it's very efficient. And so, yeah, we can see how the GDP growth rate is down here. I don't know why it's decreasing over time. It should always be 0.03 plus this stochastic element. We can see GDP growth almost linearly, and the GDP growth rate, the absolute growth is growing with the GDP because it's just a percentage of that. Okay, I mean, that's fairly straightforward. I think before I wrap it up here, I'm going to make just one kind of minor adjustment, which is I just want to see I'm going to change that run, and we're just going to take the growth rate and the absolute GDP out of the runtime plot just to see what happens with this. Yeah, it should be, this looks stochastic. Yeah, so it was just by chance that it looked like it was going down over time. Okay, and then we could do the same thing now with the GDP growth. That should grow over time. I meant this one. It's a function of GDP, but yes, we can see the stochasticity in that. And then we can see the stochasticity in, selected the wrong one again. In this, it's fairly smooth because the stochasticity doesn't add up too much as a percentage of the whole thing. So that's maybe one last thing we can change is we could say, well, a normal distribution doesn't describe very well the way GDP evolves. So we could say let's try something else. I think these are here somewhere. Let me see, norm. Yeah, here. And so we could say, okay, we want what do we want? What is a fat tail distribution? I think a Cauchy is fairly fat-tailed. It can be, yeah. So what do we want? Gamma to be yeah, it's pathological. That's perfect. It's expected value and its variance are undefined, so that's kind of nice. I think it almost doesn't matter. They don't. Yeah. They don't. It's not a really well-behaved distribution. So we could set these variables to anything, but I think x will be 0 and gamma can be anything. I guess we can set it relatively small and have a rare kind of that's a kind of events that cause a crash. Okay, so back to this. So we're going to change this to a Cauchy, and this can be let's just make it 0.5. and recompile. And opens up in my other window. And let's run it. Yes, this is really, really badly behaved, this distribution. So you get these totally crazy events. That's crazy. I guess it should be slightly positive. Wait, it's already being 0.03 plus this, but the variation is just too big for this to look sensible. So I don't know how we do this. Yeah, because there's a quite a high chance that this is a large value. I wonder if we can just make this smaller, or if that doesn't work. We'll see. So I should add one more thing. These kind of changes to these distributions, we can also do here in the configuration. Yes, exactly. So we have these discontinuous changes, and now this doesn't look real either, so we would have to think about like what kind of distribution actually makes sense. Of course, obviously, when we look at this doesn't look like real data either. But yeah, I think in level 2 I will add potential GDP, and then we can calculate the output gap and inflation. And that will then make it much more interesting, because if you have potential GDP, then well, that will be level 3 then, where you can add kind of what's the impact of inflation on then GDP again and close that loop. But I think, yeah, level 2 would just add potential GDP and just calculate that output gap between the actual GDP and the potential GDP. All right, well, I think that's it. I'm going to change this back to a normal distribution with maybe a little bit more variation. Run it once more, see what we get. Yeah, it creates a new window of this LSD every time you do that. Oh, we've got a little bit more variation here. But yeah, that's it. That's what I wanted to show for LSD. Thanks for watching. This is level 1 economic simulation. We have 3 variables. And yeah, as I go, I'm going to, in every video, add one more variable, and at least one more. And then we'll see where we get to. Yeah. Bye for now.